Camera calibration is an integral part of computer vision and robotics. Almost any project, any assignment, any task you want to do in computer vision, you have to deal with camera calibration. You need to understand how camera calibration works. In our day-to-day operations, when we are dealing with robotics projects with our customers, with our clients, we have to deal with camera calibration. We need to understand it to be able to perform the projects, to be able to perform the tasks effectively, and to deliver the results. Welcome back to the channel, guys. My name is Dhruv, and in this video I am going to specifically talk about camera extrinsics. So when talking about camera calibration, there is extrinsics and there are intrinsics. This video is going to focus on camera extrinsics. We're gonna briefly understand what camera extrinsics mean and how we can use it in code. So I'll start this video by explaining what camera extrinsics mean, how they are defined and how to use them, and then followed by that we will go into some code samples to show you how you can use camera extrinsics in Python. So camera extrinsics and intrinsics, they form part of camera calibration. The extrinsics specifically deal with the camera's pose, camera's transformation with respect to the world. Now, for those of you who do not know what transformations or coordinate transforms mean, we have a video on coordinate transforms on our channel. You can see the thumbnail of the video here, and you can feel free to go and check that out to understand how coordinate transforms work. So the camera extrinsics is basically a 4x4 transformation matrix that defines the transformation of a point from world coordinate to the camera coordinate system. Now, the world coordinate could be defined anywhere. For example, if it's a self-driving car, the world coordinate system may be defined at the position where the car started collecting the data, and the camera coordinate system moves with the camera. It's camera's local frame. So the extrinsics matrix define at any point in time the transform from the world frame to the camera frame. As we know about the transformation matrices, these are 4x4 matrices. The first 3x3 part defines the rotation, and then the three numbers on the right, three rows on the extreme right, they define the translation. Now, using this extrinsic matrix, you can transform any point in the world frame to the camera frame. So any x, y, z that is obtained in the world frame can be transformed to the camera frame using the extrinsic matrix, using simple matrix multiplication. So now let's look at the code to see how this is performed and understand the math behind it. So guys, here on the screen you can just see a sample Jupyter notebook, and in this notebook all I'm doing is showing you an example of how you can use a sample extrinsic matrix and use that extrinsic matrix to convert a point in the world frame to the camera frame. So if we go over the code over here, it's pretty straightforward. The first part here is we used SciPy to generate a rotation matrix. You could use it through other ways. You can generate a rotation matrix using other libraries or just using mathematics, but SciPy just makes it easier. And essentially we say that, you know what, let's just create a rotation matrix with the coordinate frame rotated around the z. So that's all this function is doing. It creates an identity matrix, and then it assigns a rotation to it. The rotation angle we specify is 45 degrees, and using the SciPy's function from Euler around z, we create a rotation matrix at a rotation of 45 degrees. After doing this, this is the rotation matrix we get, right? So it's pretty straightforward. And then let's create the extrinsic matrix. Over here, guys, we are just creating an extrinsic matrix, which is an identity. Identity is going to be no rotation and no translation. And then we define a translation for the camera, which is 101. This is just random. Then over here in this line, we assign the rotation to the extrinsic matrix, and then over here we assign the translation to the extrinsic matrix, and this is the final extrinsic matrix that we get. Now guys, let's assume a point in the world frame which is 50, minus 20 and 10, and we add a trailing 1 to it to make it follow the homogeneous coordinate convention. The reason we need this is so that we can do the matrix multiplication between the 4x4 transformation matrix, and the point. If the point, non-homogeneous point, would be 3x1, so we add a trailing one to make it homogeneous. Homogeneous coordinates, again, in computer vision is something that is very important. So if you're new to this concept, I suggest you read up on this. Now guys, once we have the point in the world frame, to get the point in the camera frame, it's pretty simple. All you need to do is do the matrix multiplication between the extrinsic matrix and the point in the world frame, and you'll get the point in the camera frame, which is shown here. Again, this point is in homogeneous coordinate system, so really the x, y, z would be the first three elements of this vector, which is 50, 21 and 11. 50.49, 21.21 and 11, and those are the points in the camera frame for the that correspond to the point 50 minus 20, 10 in the world frame. So guys, using this extrinsic matrix, we are able to do this transformation. So that's it for this video, guys. I just wanted to go over the extrinsic matrix and showcase how to use camera extrinsics when converting from world frame to the camera frame. Subsequently, I'll also talk about the camera intrinsic matrix in one of the upcoming videos, so stay tuned for that. If you like this video, please hit the like button, subscribe to the channel and hit the bell icon so you are notified about any new video that we upload. We continuously upload informational content about computer vision and robotics, specifically talking about the new things that come in the field of computer vision and talking about the fundamental concepts in computer vision. So if you don't want to miss this, please subscribe. Thanks a lot for watching, guys, and if you ever want to get in touch with us, here is our contact information. Feel free to get in touch and we would be happy to chat with you. Thanks again, and I'll see you in the next video.